In acid basis salt, what do you have to study? One, what is acid and base? What are indicators? Acid base properties means reactions we have to study. What is pH? What is universal indicator? From common salts, some chemicals are made that we have to study. Everything will be understood very easily, will be memorized too. Let's start first of all. What is acid? Beta, acid is chemical which when we put into water, we see a type of positively charged ions. We see one positive ion. Which one? H plus ions are seen. So what is it? A substance that gives H plus aqueous as the only positive ion in aqueous solution. Such chemicals which when we put into water, and in water when we see positive ions are there, then only one type of positive ion is seen, H plus ion. In the board, that is not asking the definition. All right. How are acids? Sour in taste. They are sour. Eat a lemon someday. How is it? Sour inside. That is citric acid. Turns blue litmus red. If you bring blue litmus paper and dip it in acid, then how it will become? It will become red. Okay. You should remember the name of some acids. Some acids like HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, and CH3COOH, CH3COOH, acetic acid. Where is it found? In vinegar. That is the vinegar that is there in home. We put in chowmein and all vinegar. That is called CH3COOH. Acha. Now we come to base. As we put acid in water, what did we find? H plus ions. When we put base in water, then what is increased? OH minus ion. A substance which increases OH minus ions in aqueous solution. Aqueous solution means the water's solution. What does the acid give in water? H plus ions. What does the base give in water? What it increases? OH minus ions it increases. Okay, it's not asking the definition. So remember, which ions come from acids? H plus. Which ions from the base? OH minus ions. All right. How are the bases in taste? They are bitter. Bitter. Bitter in taste. Your friends are bitter, bitter. I am saying bitter, bitter. Yes, how are they? Bitter friends. Bitter. Have you ever licked soap at home? Sir, what are you talking about? If a soap went into your mouth while you're bathing like this, how it tastes like? Bitter. Because what is soap? Base. So what is soap? Base. Soapy in touch. Soapy means they are slippery in touch. How are soaps? They are slippery. Turns red litmus into blue. What do these do? These turns blue into red. This turn into red. Danger. Acid means danger. It feels like it. So this is bring it like danger. So what does this do? Turn red litmus into blue. You must remember the name of some bases. NaOH, sodium hydroxide. KOH, potassium hydroxide. NH4OH, ammonium hydroxide. MgOH, whole twice, magnesium hydroxide. Calcium hydroxide. Calcium oxide. Magnesium oxide. Generally metal, like we see all the metal here, potassium, sodium, magnesium, calcium, magnesium. If the metal has oxygen or if metal has OH, we call it base. General, metal has OH or metal has O. This we call base also. So acid base we understand a little bit now. Okay, let's move ahead. Now comes indicators. Such substances that can identify whether something is acid or base. If something is acid or base, we call them indicators. So we have to memorize 3 indicators. First is litmus. This is widely heard. What color does litmus give to base? Blue. What color does it give to acid? Red. Second is turmeric, means haldi. That turmeric that we use in food, you know that stains on your shirt sometimes, turmeric. Haldi, turmeric. How it turn into base? Yellow, red. How does turn into acid? Yellow. Phenolphthalein. Phenolphthalein. How does it change the base? Pink. How does it turn acid? Colorless. How to memorize? There is a trick. I will make you memorize everything. Don't worry. Methyl orange. It is also indicator. How turn it to base? Yellow. And how does it turn to acid? Red. It becomes yellow. When in acid, it becomes red. Now, this whole indicators we have to remember it because in exam they have asked many times. How do we remember this? There is a mnemonic. What is mnemonic? It's a code. What is it? Labor, try, popcorn with mayor. This is a labor. Who is eating popcorn with whom? With the mayor. Labor, try, popcorn with mayor. If you are able to remember this line, then you would have memorized all the indicator in one go. It will be memorized in 1 minute. Labor, try, popcorn with mayor. Now understand, In labor, L means litmus, B means blue, R means red. First comes the base, then comes acid. Litmus, blue, red. First comes base, then came the acid. Try. T means turmeric, R means red, Y means yellow. That means turmeric. First comes base, then comes acid. Clear? Popcorn. Wrote this in same way. Capital P, capital P, capital C. P means phenolphthalein, P means pink, and C means colorless. So what is pink? Base. How is acid? Colorless. Leave the with. Then comes the Mayer. Look cautiously. MYR. M means methyl, methyl orange. Y yellow. R red. So yellow is base and red in acid. So pause once and memorize it quickly. Quickly take the screenshot and memorize labor. Try popcorn with the Mayer. Labor, L litmus, B blue, R red. So blue in base, red in acid. Try. T turmeric, R red, Y yellow. So turmeric is right in base, then acid it's yellow. Popcorn, PPC, phenolphthalein, pink colorless, pink in base, colorless in acid. With leave it, Mayer, MYR, M methyl, Y yellow, R red. Means yellow in base and red in acid. Can you remember it? Pause and memorize it. Comes to the question. Let's start. So look, CBSE 2023 asked a question. It is the questions from 2023 boards question. Out of the following, which compound or compounds will turn phenolphthalein solution pink? Phenolphthalein reminds me of popcorn. Popcorn. P means phenolphthalein, P meant pink, and C meant colorless. And I know first comes base and comes acid. Now what it's saying? Which compound will turn the phenolphthalein solution pink? Phenolphthalein beta, who can turn it pink? Base. So we have to find the base among this. This is CH3COOH, acetic acid, no. This HCl, no. NaOH, metal and OH, base. CaOH, hold twice, metal and OH, base. So two options are correct, B and D. Tell me everyone got the answer? Let's do the next question. Now see how many times this question and similar questions have been asked. This has been asked in CBSE 2024, then CBSE 2023, then in CBSE 2022, and then in CBSE 2021. Repeatedly such questions have been asked about phenolphthalein. What is it? There is one solution, phenolphthalein is put in it, then what happened? It turned into pink. Then he put solution B in it. Then what happened? The pink color disappeared. Then he put some drops of A. Then again it turned into pink. We have been asked the respective change in the nature of the solution are from acid to basic, basic to basic, basic to acidic, acidic to acidic. That is being asked. For once, pause and try. Comment the answer for question number 2. Pause and see how much you have learned. Come, let's do it together. So, bhai, it has again phenolphthalein, right? Phenolphthalein. So I will write popcorn, Popcorn. P means phenolphthalein now. This P means pink and this C means colorless. First comes base and then comes acid. So this becomes our base and this is my acid. See, it first turned pink. Look at it. When it was put in solution A, then what color it becomes? It pink. Pink means what type of solution is? Basic. Then when B solution is added, the pink color disappeared, mean it became colorless. Means what did it become? It become acidic. Then added drops of A into it, then again how it becomes pink. Pink means how is it? It's beta, basic again. So the answer is basic to acidic, acidic to basic. Fine, fine, fine. Basic to acidic, acidic to basic. Did you take this one? Congratulations, bye. Very good. You have learned it. Let's go ahead. So beta, you have learned a few indicators that changes color. Now let's assume someone is unable to see as they have no vision in their eyes. Since someone is blindfolded, then how would they know if something is acidic or basic? They wouldn't be able to see the colors. Suppose someone is colorblind. For such people, indicators were made, olfactory indicators. What is it? Olfactory indicator. Olfactory is related to smell. We will study in biology too. Substance whose smell changes in acidic or basic medium. By smelling, we can also say if something is acidic or basic. 3 olfactory indicators must be remembered. Onion means piyaj, vanilla essence, and clove oil means oil extracted from clove. What? Onion, vanilla, vanilla essence and clove oil. How to memorize it? I say simply, vanilla reminds me of what? Ice cream. Yes sir, ice cream, vanilla ice cream. Assume you have purchased a vanilla ice cream and someone put a clove in it. Hi, chiche, someone has put a clove in it. Pushed a clove in it. And a friend of yours came and put an onion on it. What was put on? Onion was put on. So on the vanilla ice cream, what was put on vanilla ice cream? What's put on the vanilla ice cream? Somebody has put a clove in it, someone put the onion on it, and it become olfactory indicator. Vanilla ice cream, vanilla essence, put the clove oil and add it for onion. Now what happens? These indicators, when we add base in it, so it loses smell in base. It loses the smell in base. You know the smell of onion. Put some onions in the fridge and you will know foul smell all over. Or if someone seated next to you after eating onion, what smell? So if you add base on that onion, the smell of the onion disappears. Clove has a smell of its own. You add base to the onion, then smell disappears. So what these bases do? It makes the smell disappear. And if we talk about acid, then acids retain smells. Retain smell in acid, loses smell in base. Clear now? These are olfactory indicators. Look at the question. CBSE 2023 will pause the video and comment on the answer for question 3. Do it by. Let's go. Select the pair of olfactory indicators from the following. Tell me which are the ones. Clove oil and vanilla essence, right? I got it. What else have we got? Onion and turmeric. No, turmeric changes color. Vanilla, methyl orange, color changes. Litmus paper, color change. So the first option. Next, CBSE 2020's question. A visually challenged student, the one who cannot see, has to perform a lab test to detect the presence of acid in a given solution. The acid base indicator preferred by him. What would he choose? The one who cannot see, colors of litmus paper, red cabbage. These things were not taught. This is not taught. What we taught you? Clove oil was taught. He will know by smelling. Let's move ahead. Now comes what will happen if acids we put in water. We started from here. When you put acid into water, it will give H plus ions. Look, acid produce H plus ions in water or aqueous solution, any solution of water. This is HCl acid. We put it into water. What came out? H plus ions came out. Plus aqueous, and what else become? Cl minus. Look, it will break like this, cation and anion, H plus minus and Cl. But this happens only if there is water. Without water, acid has no power. Without water, acid has no power. Like without you, your friend has no power. Likewise. Look at the second thing. Sulfuric acid, H2SO4. We put into water. How many H's are there? 2. So 2H came plus. Beside aqueous is written, means inside water. Plus what will come? SO4, 2 minus, ions of sulfates. So 2H plus and 1 SO4 and 2 minus. When will it happen? When there will be no water. See carefully. In dry state, if there is no water, no H plus ions is produced. Suppose I took dry HCl. How will I take HCl? Dry by it's a gas. I took hydrogen chloride gas, dry gas. And if there is no water, then out of hydrogen chloride, there will be no H plus ions. No H plus ions will come out. Okay, acha. H plus of acid combines with H2O to form H3O plus hydronium ions. Now you will have to remember this. Acid that is H plus water give, na? It doesn't want to stay alone. Like you don't want to live alone. You do look for someone, hai na? Like someone should be there. Koi na koi chahiye. Pyar karne wa. The same thing. He says that we won't stay alone. This H plus says we won't be alone. As soon as it gets into water, it says, water, let us join you. Water says, come. H2O gets another H and what it becomes? H3 and another O along with a positive ion. Look, H plus went inside the water and what will become? H3O, one H joined, H plus ion. We call this ion hydronium ion. If it is ever asked from you whether acids give H plus, say it does, but always write it like this. So we say acid gives hydronium ions or tension, H plus aqueous ion. If you say this acids give H plus ions in the water, then it's not completely correct. Just write it in front of this aqueous and your answer become correct. It means H plus which water? The H plus doesn't want to be alone. H plus go out of acid. In what? In water. Now what will this H plus combine with? With water. What does it become? H3O, and along with it, when you put plus. This is called hydronium ion. So either you say that what does acid give in water? Hydronium ion, H3O plus. You don't remember this? Or you can say H plus aqueous ion. Now listen, this whole terror of acid in this entire world, this acid is very dangerous, will do this. All this bhokal of acid is because of this ion. This is the strength of acid. Which one? H3O plus. H plus aqueous, both the same thing. H plus aqueous. If this is not with acid, then acid will not show its property, will not be able to turn blue litmus to red, will not be able to cause any color change. The strength of acid is finished. This H plus aqueous ion or this H3O plus hydronium ion gives common properties to all acids. If acid does not have this H plus aqueous or hydronium ion, then acid is not acid. Acid only becomes acid when it gets water. Where does this ion gets released? In water. So remember, acid becomes acid only when it gets water. Come, let me show you one thing. It comes in board very often. Preparation of HCl gas. We have to make HCl gas. A reaction is written, double displacement. We have read it in the first chapter. Which reaction is a double displacement? We took NaCl, sodium chloride. We took H2SO4, concentrated sulfuric acid. What happens in double displacement? Alta palti happens. So this Na will go and combine with SO4, and Cl will go and combine with H. Na will combine with SO4, and what did it become? Na2SO4. And this combine with HCl, and Cl come by this compound HCl gas. So this reaction, beta, you should remember this. It will be asked in exams that which reaction is produced in HCl. What would we take? We took salt. Then we put what? Sulfuric acid in it. This is an activity of NCERT 2.9. You should remember this. What did we do? We took salt and added concentrated sulfuric acid to it. And what happened here? Double displacement happened. Na combined with SO4, sodium sulfate plus bomb. Cl went and combined with H hydrogen chloride gas. See, this is made here. They have shown the same thing. We have H2SO4 and this is sodium chloride. We put H2SO4 drop by drop. And what happened? Na2SO4 and HCl gas was formed. Now this HCl gas came out. When this HCl gas came out of here, so we bought the litmus paper. But listen to this carefully. We brought dry blue litmus. What is it? HCl gas. What we bought? Dry blue litmus. No water is there. Now tell me, will the color of litmus change? No, it won't. Why? Why it won't change? Because HCl gas is there, no water. What is litmus like? Dry blue litmus. If there was water in this litmus, then H plus aqueous would have come out of its acid and acid would have shown its powers. But since as the dry blue litmus, the acid is not acid. So what will happen to the dry blue litmus? No color change. Bhai sahab. So we put HCl on what? On dry blue litmus and no color change, because HCl is a gas and it's dry. It doesn't have water. Litmus doesn't have water. Nowhere water. So acid is not acid. Then there is no color change. The blue should have turned into red, but it's not. See what is next? Moist blue litmus. What did I put in? Moist. I added little bit water. What did I get? We bought moist litmus paper in the color blue. We bought moist. So what did the HCl get? What did get out of it? Beta, water, H2O, moist. As soon as it got the water, acid became acid. And what would happen to moist blue litmus? It would become red. So remember this, acid shows its property in water. If HCl gas is written, then what is gas? Gas is dry. As long as it would know moist litmus, then it won't change to red color. Okay. See, this is one reaction. HCl gas reacts with water. It's asked in the exam. HCl gas, which was formed, this hydrogen chloride, this was made to react with water. What happens? Beta, this H plus got out and combined with H2O. What happens? H plus got out and combined with H2O. What did it become? H3O plus hydronium. And the Cl minus ion came out as it is. It's very simple. It was very simple. Reaction of any acid with the water, reaction of any acid with the waters. Remove H plus and add it to water, H3O plus, and whatever is negative, write it separately. You should remember this reaction. And this one too, preparation of HCl should be remembered. Slowly I will make you memorize it. Don't worry. We will do a question. The question is come again. I will make you do a lot of questions from the board CBSE 2023. Hydronium ions are formed by the reaction between. He is saying that the hydronium ions, hydronium means H3O plus 1s. Hydronium ions are formed by the reaction between NaOH water. It won't be formed by this here. It won't be formed by NaOH water. Okay. Hydrogen chloride gas water. Yeah, this would have formed this. What? HCl gas and water. Now tell me, what is the hydronium ion be formed? Will it be or not? HCl gas and water. What will happen? Here H plus will released, will combine with water. What will happen? H3O plus. And what has come out of here? Cl minus. Is it clear? Next. CBSE 2025, it came board in this year. In order to prepare dry hydrogen chloride gas. Now read one more thing. See one more point. This was written here. This here. This is why you leave this master. Now see. If I have to do this experiment properly, then what kind of HCl do I need? I need it dry. If HCl would be dry, then only I will able to do it this experiment. That I test it with dry litmus or with moist. If there would be a little water in the HCl gas, there would be a little bit of moisture in the HCl gas, then this experiment will not happen. That is why we put here a drying tube. What do we put into it? We put calcium chloride. What do we put in? Calcium chloride. What it does? It absorbs water. What it does? Absorbs the water. Suppose the HCl gas that got released, there must be some moisture in it, like water vapor. Water vapors are everywhere in air. So there must be some water vapors in HCl gas. This HCl gas, there might be some water vapor in it. So what would the calcium chloride do? It will absorb the vapor so that the experiment is conducted properly. That's why it's called drying tube. It is dries the HCl up. See, this question is on CBSE 2025. Now you're thinking that, sir, the question came this year. That's why you're teaching us. See the last year's lecture. That's it. I taught the same thing and came in exam. In order to prepare dry hydrogen chloride gas in humid atmosphere, they are saying that the water is humid. The gas produced is passed through GAR tube. What is it? Passed through GAR tube. Drying tube, which contains, what would contain in drying tube? CaCl2, calcium chloride. We got it? Calcium hydroxide, calcium oxide. We pass through with drying tube. And what is in there? Calcium chloride. What is that? Calcium chloride. What is it for? So we can dry the HCl up. Pass through a GAR tube, drying tube, which contains calcium chloride. Very good, bhai. Let's go. Now let's see what the base would do if it goes in water. It's very simple. What does the acid give upon in the water? H plus A. Hey, H plus aqueous or H3O plus. Acha. Similarly, when we put base in water, like when we took NaOH and put it in water, very simple. What do we want? Remove plus, this is minus, then Na plus, aqueous means in water, OH minus, aqueous means in water. KOH, K plus, OH minus. NGOH whole twice. So magnesium gets 2 plus, valency is 2. So MgOH plus and 2OH minus came out. In short, upon going into water, what ions does the bases give or increases? OH minus ions. What is called? Hydroxyl ion. What is called? Hydroxyl ion. OH minus. Okay. So base give OH minus. Now listen, there is a special type of base which is completely dissolved in water. There is a special type of base which completely dissolved in water. We call it alkali. What we call it? Alkali. Some bases are water soluble. These are called alkalis. Some bases in water are soluble. Those we call alkalis. There are 3 alkalis that you must remember. One is sodium hydroxide, NaOH, potassium hydroxide, KOH, ammonium hydroxide, NH4OH. You must remember these 3. They are highly soluble. Very good alkali. Alkali, water soluble base. Remember it. Some bases are water soluble. These are called alkalis. You should remember 3: KOH, NOH, NH4OH. There are others also who are little soluble. MgOH whole twice, calcium hydroxide, barium hydroxide. There are some, okay, what is this? Look, base but not alkali. Listen carefully. Bases are of 2 types. One that are soluble in water. What do we call them? Alkali. One that is not soluble in water, insoluble, we don't call them alkali. These are also bases. So base but not alkali. There will be one base, there is water soluble. They are alkali. Who are they? Recall KOH, NaOH, NH4OH. These are three. You must remember KOH, NaOH, NH4. There are some bases which are soluble in water, means whatever is left, they are not alkali. Base but not alkali. Zinc hydroxide, FeOH whole twice, copper hydroxide. What are all this? Not alkali. Anything you can write. Magnesium oxide, anything. What are they? Not alkali. Only these three are ones you must remember: KOH, NH4H. One more we consider COH whole twice. This is also considered COH whole twice. But you must remember these three. Base which are water soluble, alkali. And some bases are not alkali. Some bases are not alkali, not water soluble. Let's go. Look at the question from CBSE 2025. Write the formula of ions which acid and bases generate in water solutions. Formula of those ions. So if we see acid, what do we give? H plus aqueous and H3O plus it gives. What ions does the base give in water solutions? OH minus aqueous. Dry HCL gas does not change the color of dry litmus paper. Why? Please tell me. The dry HCL gas is not changing the color of litmus. Whose color? Dry litmus. Why? Why? Because it will not show its acidic properties. Why? Because water is not present. The same is written. Because dry HCL gas without water cannot give H plus aqueous ions or H3O plus hydronium ions, which is responsible for its acidic property. The acidic property of acid comes from here, sahab. If dry HCl is there and dry litmus is there, then there is no water. And there is no water, then this will not form. And if this doesn't form, then acid will not show its any properties. So this is the answer, that without water cannot give these ions, which is responsible for its acidic properties. See, it came here in the 2025. I taught you this last year. Let's go by. Let's see further. Diluting an acid. Now, what is diluting? Suppose one acid is highly concentrated, right? It is highly concentrated. It is highly dangerous. We have to make it light. Let's listen to it with love. What is it? Add some water. This is called diluting an acid. Mixing concentrated acid, add water. Concentrated means very dense. What? Dense, not donkey. Dense, dense. So adding water, very dense acid, we call it diluting an acid. Now listen carefully, very carefully. Recall Athu. What? You must have seen in India, people spit anywhere. Athu. What does Athu mean? First catch it, then we will understand. What does Athu mean? Acid to water. Catch it first. Acid to water. Athu. Acid to water. What am I explaining? If you have to dilute acid, water should be there, not concentrated. Then always add acid dropwise. Don't add water directly into concentrated acid. Never add water into acid to dilute acid. Add acid into water. Acid to water. Why am I saying this? Listen. Acid plus water is highly exothermic. Acid and water together release too much heat. Very much beta heat is released. It is exothermic reaction. Too much heat is released. Too much heat. If water is added to concentrated acid, now think I have 10 ml acid here and you add water. Then which is dangerous? Water or acid? Water or acid? Which is dangerous? 10 ml of acid was already there. You put water into it. Frog! The whole beaker would explode and acid will spread on your face and hands. You will burn. So, if water is added to concentrated acid, the heat generated may cause the mixture to splash out and cause burns. We will get burnt. The glass container can also break due to heat given out. The heat will be so much the glass will blow. Never add water into acid. Acid is very dangerous. If there is more acid and you add it, then baram. So what should we do? What should we do? What should we do? What should we do? Acid to water. We will have more water first. We would put water and then add dropwise acid. Which is dangerous? Acid. So we add dropwise. Slowly we will add. So that's why never add water to acid. Never add. Always add acid slowly to water. with constant stirring. Means take water in the beaker first, put 1 drop of acid, yes, nothing happened. Tuck, 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 stirred. 1 drop more, nothing happened, stirred. 1 drop acid more. Always add acid slowly to water with constant stirring. Okay, why should we do it? Because acid and water's reaction is highly exothermic. If you will put water and acid, so the acid is more. Upon putting water into it, then dhamaka. So safe. Take some water. There is nothing to fear in it. Add some little acid. Add little bit acid. No worries. So Athu, acid to water. Always add what? Add water to acid. Come. CBSE term 121-2022. Concentrated H2SO4 is diluted by adding drop by drop. What would happen? Acid to water. So what to do next? Water to acid? No. Acid to water with constant stirring. That's correct. Let's see next. Acid and alkalis, electric current. Now understand. Here we have some solution here and some wires in and a bulb. Now, this circuit will only complete when electricity passes through the solution. See, here is battery. If I see the way of the current, then here is battery. If the current starts from here, 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 now how will the current reach here? It will go through the solution and then it went here and then went here and then went here. This circuit will only get completed when the solution lets the current flow, like you have seen in water. Pure water current doesn't flow. If you add a little bit of salt, then the current flows. Solution has to be conducting. Let's understand this activity. Now listen carefully. Electric current through the solution is carried by ions. If a solution has to make electric current flow, then what should be the solution have? It should have ions. Very important. If a solution has to conduct the current, then it should have ions. This bulb will only light up. The current will flow from here, and then it will break. The current won't break. From within the solution, whether the water or whatever, it should go through. Now, any solution will only flow when it has ions. Electric current through solution is carried by ions. Now, listen carefully. The acid solution of acids, HCl, H2SO4, HNO3, nitric acid, CH3COH, acetic acid, generate ions. These generate ions, H plus ions, Cl minus ions, and hence they conduct electricity. Then by bulb, will glow. Alkalis also generate ions. Alkalis, water soluble, OH minus, NaOH, KOH, NH4OH, ammonium hydroxide, and hence conduct electricity. Bulb start glowing. Na plus OH minus. From here, if ions are generated, then current will flow, and if current flows, then bulb will glow. Attention, important. Glucose and alcohol. Glucose and alcohol. Alcohol we have to read in 4th chapter. All right, carbon, alcohol C2H5OH and glucose C6H12O6 do not generate ions. These are no ions in their solution. That's why they don't conduct electricity and the bulb will not glow. That's it. Acids have ions, electricity will be there, the bulb will glow. Alkali has ions and the bulb will glow. Glucose and alcohol don't have ions, so the bulb will not glow. CBSE 2025. Sir, you must have taught this. Look at last year, same page. CBSE 2025. This question came the claim question. Design an experimental setup to demonstrate that alcohol and glucose contain hydrogen but are not categorized as acids. What an interesting saying. Does glucose have hydrogen? Yes. Does alcohol have hydrogen? Yes. But this is not acid. They are not acidic because they don't generate ions. They don't give H plus aqueous. So everything that has hydrogen is not necessarily acid, beta. It's not necessary. Every girl that laughs looking at you doesn't necessarily love you. She may be a little bit mad. Always laughs. To smile is the allure of a beautiful girl who thinks that his love is big as donkey. Yes, bhai. Then what is saying? Alcohol and glucose contains hydrogen but are not categorized as acids. Acid, they are not acid. Why? Because they don't generate ions. Also give the reason to justify this fact. So beta, draw this thing. What reason will you give that this don't generate ions and bulb doesn't glow? We have to draw this setup. We have to draw it like this and attach here. Clear? So you must know this diagram that by in the case of alcohol and glucose, there are no ions. This is the reason. Reaction with metal. Now we have to come to reaction of acid and metal. Acids reaction with metal. Reaction of acid with metal. We have to read a small rule of base. Look, metals above hydrogen in activity series displace hydrogen from acid. Do remember this activity series? You have read it in the first chapter, activity series. Do you remember? कुरीनाल, कार मांगो ऑल्टो, जिसको फेर लेकर हम चले मथुरा साथ घूमने. I'll make you memorize it. No tension, it's not very useful in this chapter. It will be used in the next chapter, then I will tell you. All the metals that are above hydrogen. Metals above hydrogen in this activity series, all those are above hydrogen, displaces hydrogen from acid. They get hydrogen gas from acid. If I make a metal reacts with acid, and if this metal is above hydrogen, then what will it do? We will take out from acid what? Hydrogen gas, very important. That is why hydrogen gas is produced. So we make zinc reaction with dilute sulfuric acid, where is zinc? Above hydrogen. So what will it do? It will take out hydrogen from this, and zinc itself got it to it, zinc sulfate formed. So if you look carefully, what reaction is this? Displacement reaction. Zinc was above it, it got inside, it removed this one out. So this is very important reaction to remember. Zinc plus dilute H2SO4, hydrogen gets out and zinc gets in. This is the experimental setup. What are we showing at this experimental setup? Look, what is here? Zinc granules. Granules means tiny zinc. Why do we take tiny zinc? So that surface area increases. It's never asked in exam, maybe asked in 26. That why it takes zinc granules to increase surface area. So that's the reaction is more. Then we put dilute sulfuric acid. Now what will happen? This reaction will happen. Hydrogen gas will come out. So here comes hydrogen gas, hydrogen gas, hydrogen gas. So we put solution of soap into hydrogen gas and we saw bubble is formed. Why are bubble formed? Because it's gas. It would want to come outside. Bubble appear because gas is released. If asked in exam, why does bubble appear? Because gas is released. Now, how to know if this is hydrogen gas? We have read it in first chapter that if you bring a burning splinter or burning matchstick splinter means that you wooden broom, which is used to water removal, take a thin stick and burn it. Burning splinter thin, or bring a matchstick or bring a candle. So hydrogen, what you used to do? Burns with pop sound. You remember? Hydrogen burns with pop sound. So what happened? H2 gas burns with pop sound and extinguishes the candle or glowing splinter. Extinguishes the candle or glowing splinter or a glowing matchstick. It will extinguish that and pop sound, it will burn. Test for hydrogen gas. It's clear for this reaction. Let's go bhai. Zinc plus H2SO4 dilute hydrogen plus zinc sulfate. Metal plus acid gives salt plus hydrogen. Salt, this is salt. We will memorize about it. Don't take tension. Reaction of base with metal. Now you must memorize one specific reaction in this. This reaction is very important. It's asked for every year. What is the reaction of base with metal? If you react base with metal, then also hydrogen gas is released. But there is only one metal in your syllabus, zinc. If we react zinc with sulfuric acid, hydrogen. If we react zinc with NaOH, then also hydrogen. See, base plus metal gives hydrogen gas and salt. So what did we do? Took base and NaOH aqueous, this is base, and we took zinc. What do? We have to take hydrogen gas, and here one zincate is formed. Sodium zinc, Na2ZNO2. You must remember this. Na2ZNO2. To remember this, Na2ZNO2, I made this. What did I make? Na2 Jana2. Look, it's simple. Acids reaction with zinc, H2SO4 with zinc, hydrogen gas. Bases reaction with zinc, NaOH zinc, again hydrogen comes out. Salt is a little different. What is it? Na2 Zana2. Na2 means Na2, Zan-R2 means zinc and O2, Zan-R2. Na2 Zana2, you can memorize it like this. It's clear, bhai? The rest of the metals don't give this reaction. Reaction does not happen with all metals. In case of acid beta, all the metals in the above hydrogen, all of them give this reaction. But this case of base, you have to remember only zinc. The rest of the metals don't give. Look at this question, CBSE 2024. You will do it. All right. Let's mark this as homework. Pause the video and comment the answer for question number 9. It will come in 2024, 2023 and 2025. No, not 25. It will come in 26. It will come, bhai. It always comes. You do comment. Let's move further. A student adds zinc granules to dilute sulfuric acid in one test tube and to sodium hydroxide in another. A gas is evolved in both cases. Name the gas and how would you test it? Now look at this question. It contains CBSE 2025, 2024, 2018, 2015. Now it might come in 2026. How many times it has been repeated? How can the question come beyond this note? What is it saying? So what is it saying? Zinc granules react with what? Dilute sulfuric acid. What will be released? Hydrogen. And to sodium hydroxide in another. Sodium hydroxide, what is it, beta? What is this? Is base. Zinc plus NaOH, this is base. What will it be released from this? Hydrogen. A gas is evolved in both cases, hydrogen gas, all right. Name the gas and how would you test it? Hydrogen gas is evolved. What is the test for hydrogen gas? What is it? When a burning matchstick or a glowing splinter is brought near the gas, H2 gas burns with pop sound and extinguishes a glowing flame. It does extinguish. Why? Because hydrogen is combustible but not a supporter of combustion. It will burn itself but extinguishes the fire. Combustible but not supporter of combustion. All right. Now let's see the reaction. Instead of zinc 2HO4 and hydrogen comes out. Zinc with NaOH, hydrogen comes out. What has become? Na2, Na2. Clear? Yes. Now reaction of metal carbonate with acid. Metal carbonate, if you see such thing with metal, CO3, or metal hydrogen carbonate, what you see? HCO3, like this, sodium with metal, CO3. What does it become? Sodium carbonate. Or if this is with sodium, HCO3, what is it? Hydrogen carbonate, hydrogen and carbonate. It is also bicarbonate, we can say, sodium bicarbonate. So if you see carbonate of sodium, CO3, or sodium's bicarbonate, hydrogen carbonate, HCO3, is very simple, beta. Listen, either it is carbonate or hydrogen carbonate of metal. If you see any of these, look at both. Can you write the carbon dioxide in it? Yes. So as you react with acid, carbon dioxide gas is the one thing they will release. You can see it. A water is released and one salt is formed. All right, let's understand. Catch this. Now, HCl and sodium carbonate. What should be released first? Carbon dioxide. Here it is. What else? Water. Here it is. Now what will be salt? From here Cl, from here Na, from here NaCl will be salt. Reaction complete. Be it carbonate of any metal, here is it is for sodium, magnesium carbonate, calcium carbonate, copper carbonate. It is very simple. Anywhere if it's metal carbonate, acid, you didn't memorize anything, nothing. Bhai, I should remember the rules. We will make reactions in the exam. Yes, not like we will write anything. Metal carbonate and acid, or metals hydrogen carbonate or acid, what? Carbon dioxide, water, salt. Right, finished. Look, NHCO3 or acid, carbon dioxide, water and salt. What will become? Na2SO4. Tell me it's clear. Now the equation will be done. Usually these questions come for sodium, but it may happen that ask for calcium carbonate or magnesium carbonate. All right, it may ask for bicarbonate of magnesium. Whether it is metals carbonate or acids bicarbonate, what will be? Carbon dioxide. Now what is asked in exam, which is very important, that is test for carbon dioxide gas. How will we know if the gas is carbon dioxide? When we pass the carbon dioxide gas through lime water, look, lime means calcium. I told in the first chapter, lime means calcium. Water means hydroxide, calcium hydroxide. Lime water, yeah, slake lime, we mix that in water, completely dissolve it, aqueous lime water. If carbon dioxide is put in lime water, what will happen? It become calcium carbonate. How is calcium carbonate? White precipitate, it's insoluble. So when we pass carbon dioxide through lime water, then precipitate is formed. So how does it look? Milky, because it's precipitate inside of what? Calcium carbonate. You must memorize this reaction. That if carbon dioxide is passed through lime water, that means calcium hydroxide. This is test, carbon dioxide. Remember this. What will be formed? Calcium carbonate. What kind of? White precipitate, insoluble. What kind of? Milky, because that's why happening. Milky, this means milky is happening. Now let's move ahead. This got formed along with water. Now the story moves ahead. Suppose this lime water, that is milky, I pass more carbon dioxide. In this I put more carbon dioxide. One passing excess of carbon dioxide. Till here it was milky. I pass more carbon dioxide. If I put, then what happened? This was calcium carbonate that was formed. This is water. We added more carbon dioxide in it. This is formed. We add more carbon dioxide in what formed? calcium hydrogen carbonate, CaHCO3 whole twice, or this can be called as calcium bicarbonate. This is soluble. What kind of it? It is soluble. Means the precipitate which is formed, that is now disappeared. Solution again became clear. So now what happened? That in lime water we added carbon dioxide. What it formed? This white precipitate of calcium carbonate. It is milky. When in excess, when carbon dioxide buzz, we had more carbon dioxide in the solution, then this was formed, and this is soluble, so milkiness disappeared on passing excess of CO2. This test of carbon dioxide should be remembered. On passing carbon dioxide through lime water, what happens? Lime water turns milky. On passing excess of CO2, milkiness disappeared. So this 1 and this 2, both equation, cause and memorize once. In exam it's coming. Carbon dioxide will make lime water milky. If you pass more, then milkiness disappear. Why? Because this is insoluble, this is not soluble. They have asked why this is milkiness, why it disappeared. See, in CBSE 2023, this question was directly picked up and they had made this one. That one, metals carbonate and acid. See, metal carbonate or acid, what gives out? Carbon dioxide gas came out. So this is sodium carbonate or acid. What came out? Carbon dioxide. And carbon dioxide is, what did we put in it? Calcium hydroxide, means that we put in lime water. Now they ask that tell what will happen to lime water. So tell what will happen. Lime water will turn milky. On passing excess of carbon dioxide, milkiness disappear. Write the two equations, both equation you should know. Clear? Carbon dioxide test is clear. Lime water turns milky. Excess fast, milkiness disappeared. These are the two reactions. And with this question comes, because this is carbon dioxide comes out and then lime water gets milky, game starts. Next is neutralization. Neutralization. Now what is neutralization? Clash and mixture of both base and meeting that happens. Clash of mixture. Little quarrel where love happens, where fight happens. Happens or not happen? Right? You keep saying I don't like your face. You keep saying I don't like your face. Silly girl, you don't even understand this much. You are my acid and I am your base. Wah. Don't say it, otherwise you will get like So acid-base reaction is their union. Whenever acid and base meet, then salt water formed. What formed? Salt water. From the reaction of acid and base, salt and water. No need to remember any acid and base reaction of the world. What will acid and base make? Water and salt. See, how did you make? Here from acid comes out H plus. From base comes out OH minus. Now see, H and OH together, what they become? H2O, water. What is left? Na and Cl. What become? NaCl, salt. Simple. Second, acid and base. Acid base reaction, salt and water. Listen, from here H plus, from here OH minus. This time there is 2H and 2OH. That means 2H2O will be formed. They formed. And calcium is combined with this, with salt. It's formed calcium sulfate. See, same reaction is given. What comes from acid? H plus. What comes from base? OH minus. You get salt water. Acid and base reacts to give salt and water. Bhai, don't learn reaction. Understand the story. You will also remember it. But sometimes it's concept. And like I've asked you that KOH plus HCl, what it become? You try to remember it. Base, acid. What will be formed? One is water, H2O. Here from OH minus, from here H plus, H2O. And what will happen? K combined with Cl, salt. So water and salt comes from acid base. Now listen to the further story. We will get to the reaction of metal oxides with acid. Metal oxide. Metal means copper, magnesium, calcium. Reaction of their oxide with acid. We take metal, copper oxide. We take calcium oxide, oxide of magnesium. Why metal? When we react them with acid, we saw salt water is formed. What it forms? Salt water is formed. But who reacts to acid to form salt and water? Base. This means how are metal oxides? They are base. This is written here. Generally, metal oxides are basic in nature because they react with acids to give salt and water. So, these metal oxides, beta, how are they in nature? Basic. If asked in exam, because it reacts with acid to form salt water. One reaction and color you must learn because they asked in exam. We took metal oxide, oxide of copper reacted with what? Acid. Metal oxide, oxide of metal, how is it? Basic. Base plus acid, salt and water. So it's water, H2O forms, and salt, cupric chloride, CuCl2. You have learned this reaction. So simple. Metals oxide. How is metal oxide? Copper oxide, magnesium oxide, calcium oxide. Don't say zinc oxide. We will understand in next chapter. Don't say that. Its reaction is HCl acid. What formed? Water and CuCl2, cupric chloride. Color should be learned. The copper oxide is black color and the cupric chloride, that is in blue-green color. This color, beta, you should remember. Simple. Cupric chloride, blue-green color. Okay. Just opposite it, what we did with metal oxide reacted with acid. Opposite to that, do it. Metal oxide with acid. So non-metals oxide with base. Reaction of non-metal oxide with base. Which are non-metal? Non-metal carbon, nitrogen, phosphorus, sulfur. They are oxides, are sulfur dioxide, sulfur trioxide, carbon dioxide, nitrogen dioxide. So we pick carbon dioxide, oxide of non-metal, reaction of non-metal oxide with base. What is formed? Salt. Salt water again formed, again salt water. This means what is non-metals oxide? It's acid. How are non-metals oxide? They are acidic. This is written here. Generally, non-metal oxides are acidic in nature. Why? Because they react with base to give salt. Who reacting with base to give salt water? Acid. So non-metal oxide are what? Acidic. Metals oxide are basic. Clear? One reaction, carbon dioxide with lime water. This is what we have learnt. Carbon dioxide, oxide of non-metal. How is it? Of non-metal, basic. Sorry, how will be the oxide of non-metal? Acidic. And how was it? Is basic. So this is base and acids reaction. This is base and this is acids reaction. What will be formed? Water. So H2O and salt, calcium, carbonate, lime water turns milky. Is it clear? Very good, bhai. Now look at this question. CBSE 2025, 24, CBSE 2023, CBSE 2022, CBSE 2021. Arey bhai sahab, this is similar question like this has been asked so many times. It might also come in 26. A student took a small amount of copper oxide. What does he take? A copper oxide. And what he did? In a conical flask and added dilute HCl to it. Acid, metal oxide base. So what will be formed? Acid base reaction, salt and water. Right. Write the name of the compound formed and its color. So, which is the compound is formed? Cupric chloride, and its color is blue-green. Written here, cupric chloride, blue-green. Write a balanced chemical equation. So, bhai, we took CuO, metal oxide, and this what we found? Water and salt. It's clear? Carry on. Next is what? Consider the following reaction. CBSE 2025, 2020, 2018, 2015. This or exact similar question has been asked this many times. What do they say? Consider the following reaction. Dilute hydrochloric acid reacts with sodium hydroxide. Written HCl plus NaOH. Magnesium oxide reacts with dilute hydrochloric acid. Magnesium oxide, dilute hydrochloric acid. Carbon dioxide reacts with sodium hydroxide. Carbon dioxide, sodium hydroxide. We have written dilute HCl, NaOH. This is one written. And written this one reaction. It is found that in each case, what we found? Just think about it comfortably. What is HCl? Acid. What is NaOH? Base, salt and water. What is the oxide of metal? Basic. What is in front? Acid, salt and water. What is the oxide of non-metal? Acidic. What is in front of it? Base, salt and water. So what will be formed in case salt and water is formed? There is an important thing. I am informing you. You to remember this. You just have seen the oxides of non-metal. Non-metal like carbon, sulfur, nitrogen, phosphorus. You have seen their oxides. Carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide. They are all what? Beta? Acidic. They are all what? Acidic. They react with base to form salt water. Carbon dioxide, acidic. What will it do? If you take a moist blue litmus, it will turn that into red. This one is moist blue litmus. What are these gases? Acidic. In your syllabus, there is a basic gas which is ammonia. It's not directly related to circuit, but remember, there is a basic gas also, that is ammonia. Okay, let's move ahead. Now is strength of acid and base. We will learn strengths of acid base later. First, I will tell you which ones are strong acid. You should memorize them directly. Sulfuric acid, nitric acid. Sulfuric acid is in the syllabus. There are many others. You just remember this one. Sulfuric acid, hydrochloric acid, nitric acid. How are they strong? Why are they strong? What is the job of acid? To give H plus in water. So they give a lot of H plus in water, gives more concentration of H plus ions. They give lots of concentration of H plus aqueous ions, means lot of it gives. There are two weak acids. One, the vinegar, acetic acid, CHCOOH, and the one is carbonic acid, H2CO3. How are they weak? Others, like citric acid found in lemon, lactic acid in milk, they are also weak. Generally, the organic acid, those that naturally occur, generally they are weak. Why they are weak? Gives less concentration of H plus aqueous. Memorize the strong acid, trying to remember. HCl, H2SO4, HNO. Sulfuric acid, hyalochloric acid, nitric acid. Weak. Acetic acid, carbonic acid. Okay. Now comes to base. There are strong bases. So there are three strong bases. Have to remember: KOH, NaOH, COH whole twice. Sodium hydroxide, potassium hydroxide, and calcium hydroxide. Why? They gives more concentration of OH minus ions. Bhai, what are bases? Gives OH minus. So why are they strong? Because they gives lot of OH minus ion. Acha. Which are weak bases? Besides this, anything you can at an exam weak base. But remember one, NH4OH. How is this weak? Remember strong ones, three strong: KOH, NaOH, and calcium hydroxide. Okay. Rest all are weak except this. This is special: ammonium hydroxide, weak base. Others like copper hydroxide, zinc hydroxide, they are weak. Why are they weak? They gives less concentration of OH ions. They ask an exam, justify your answer. Why this is a strong base and this is weak? Why is KOH strong? Because it has greater concentration of OH ions. So three strong acids, repeat after me: hydrochloric acid, sulfuric acid, nitric acid. Three strong bases: KOH, NaOH, calcium hydroxide, COH whole twice. Weak acids: acetic acid, CHCOOH, carbolic acid, H2CO3. You will have to memorize it. Weak base, remember this one, ammonium hydroxide. Remember, it's weak base. Okay, bhai, let's move ahead. Now we are going to determine the strength of acid and bases, which is more strong, which is weak. Bhai, some maths. I have already made it memorized. Now we will use math. So what happens? You have to calculate pH. What is pH tells us? Measures H plus ions concentration in a solution. pH tells us how many H plus ions are there in a solution. The more H plus ions, the more acidic it will be, and less basic. It's very simple. So we have to make pH scale. We will study the pH paper later. For now, understand this is number of pH: 0, 1, 2, 3, 4 to 14. So the pH scale has numbering from 0 to 14. If the pH scale is less than 7, if pH value is less than 7, how is the substance? Acidic. If pH is less than 7, anything is acidic. The lower the number, the more acidic it will be. If anything's pH is 1, then it's very acidic, strong acid. And if something pH is 5, then weak acid. If the pH value of something is greater than 7, 8, 9, 10, 11, 12, 13, 14, then what is this? It's base. pH is greater than 7, base. pH is less than 7, acid. If I say there is chemical whose pH is full, now tell me citrus or base. What is it? Less than 7. What is it? Acid. And more than 7 is base. If pH is something is 7, then it's beta neutral. That's like water, pure water. Pure water beta. What is pure water? What is the pH of pure water? 7, neutral, neither acid nor base. Now understand one more thing. More the H plus concentration, lower the pH, and the more acidic that thing is, meaning the value of pH beta, the lesser it is, higher is the concentration of H plus, and the higher the H plus, the more acidic that thing is, meaning the pH and H plus are quite opposite. Now listen carefully. I told that H plus concentration is too much. How is it? Strong acid it would be, and strong acid's pH is less. This is what I'm trying to say. More H plus ion concentration. If the H plus concentration is more, then how the pH would be? It would be less, and how that substance would be? Quite acidic. So the pH of very strong acid will be lesser, and H plus concentration will be greater. Clear? 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 Okay, bhai. Now let's do question. CBSE 2025, 2024, 2023, 2022, 2021. Asking again and again the similar question. Phenolphthalein turns pink in a solution. What can you infer about the pH of this solution? Question number 13. Comment down. The answer should come and pausing the video. Phenolphthalein pink. Phenolphthalein always remind me of popcorn. Popcorn. Phenolphthalein, what does it do? Pink and here colorless, isn't it? It shows pink in which? First comes base, then acidic. So the phenolphthalein turns pink in a solution. If it is giving pink, then the solution is what? It's basic. Now tell me, what can you infer about the pH of solution? What is the pH of base? Always greater than 7. So you can say that pH must be greater than 7. Greater than 7, 8, 9, 10. It could be 7.5, even 7.1, 8, 9, 10, 11, 12, 13, 14. Get it? Next, CBSE 2025. What are they asking? Now look at this. Is the last year this question have come. A solution has a pH of 7. How is the solution? 7 meaning neutral. Lesser than 7, acidic. Greater than 7, basic. And 7 is neutral. Name a compound you would use to increase its pH. How much is something's pH? Something's pH is 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. If something's pH is 7, they say what to put into this to increase its pH. Increase means it should reach 8, 9, 10 something. What to pour in it? Let's pour base. It will pour base and pH will increase. So what should be put into it so the pH of this increases? So the answer of the first one is to put some base. Second, decrease its pH. The pH lesser than 7 meaning it's acidic. What should we mix in it? Let's mix acid. Actually, it has give you water. The solution has a pH of 7. So it's pure water, pH 7. It says that pH is to be increased. Add, then increase it. How is the solution more than 7? Basic. So what should we add in it? Base. Now it's saying pH is to be reduced. How is the solution backwards? Acidic. So add acid. It's here. Next, CBSE 2025 came in boards last year. Let's see. The following table. Page value of 4 solution A, B, C, D on pH scale. The solution A, B, C, D are strong acid, weak acid, neutral, strong base. What are they? Do pause the video once and comment down the question 15. It will be done easily. See, I am going to start with pH 7. There is a B on pH 7. pH 7 means neutral. It's quite definite. Now let's move to it. Now see, more than pH 7. More than pH 7 is base. And this is quite far from 7. It's on 13, meaning very strong base. So I have written SB. Strong base. Now let's see less than pH 7. This also, this also. Lesser the pH, more the H plus, more the acid. Meaning the substance, the pH 3 it's hell a lot of acid. So how is this? Strong acid. Lesser the pH, stronger the acid. Its pH is also less. This is also less than 7. We call this weak acid. In comparison to this one is weak, right? This would be more acidic. It's lot less than pH 7. This is more acidic. This one is less. So let's do it. A weak acid, B neutral, C strong base, D strong acid. A weak acid, B neutral, C strong base, D strong acid. Option C. Tell me you got them right? Bahut badhiya. Now what's the next? CBSE term 1 to 2021-2022. It's a good question. Consider the pH value of the following acidic samples. The decreasing order of their H plus ions concentration. Decreasing order of H plus. Now I know one thing for the fact that pH order and H plus's order, it will be opposite because more the pH, less the H plus. So I will make the order of pH instead. Let's make the pH order here. So the value of the highest pH is this one, 3. After this come pH of which one? This one, 4. After the pH, which one? 1. This will be pH of which one? 2. See, the highest pH is this, then this, then this, then this. So I made an order of pH 3, 4, 1, 2. Now the order of H plus, this would be opposite of it. We have to turn it opposite, meaning smallest of the 3, then 4, then 1, then 2. We turn it opposite. The one had the highest pH, so H plus goes lowest. What is asking the question? Decreasing order, meaning big to small. So highest number is 2, then 1, then 4, then 3. 2, 1, 4, 3. Option C. Say out loud if you got it. pH and H plus is always opposite. I took the pH order, highest of this, and then this, then this, and this. This 3, 4, 1, 2. In case of H plus is quite over the 3 the smaller, 4 is the bigger, 1 is the bigger, then 2 is the bigger. Decreasing order, then big to small. Let's go bhai. Move ahead. Next is universal indicator. Now let's understand. The pH that we had used to tell us that the substance is acid or base. It also briefly told us that it's strong acid or strong base. Now suppose someone don't want to know about your numbers, just want to understand the colors. So if we need to understand the colors, we take universal indicator. One should remember this definition. This tells us that whether the substance is acid or base and how much strong is the acid and how much strong is the base. Substance which detects nature of chemical as acid or base and also measures the strength of it. First thing, the nature, its universal indicator will tell the nature whether something is acid or base and will also tell the strength, how much of strong acid and how much weak base. This is definition must be remembered. Those substance who tells you the nature, either acid or base, and the strength. This universal indicator are a lot of types. We have to study only one example, that is pH paper. It looks like this. Here goes violet, indigo, blue, green, yellow, orange and red. These are the colors: violet, green, blue, yellow, orange, and last it's red. If you will notice that with the light, the colors such in Vibgyor, so I wrote violet, indigo, blue, green, yellow, orange, red. If you notice the word Vibgyor carefully, you must have heard about Vibgyor: violet, indigo, blue, green, yellow, orange, red. If I notice it carefully, I will realize that which is the middle letter in this. Here three letters, there are three letters. Vibgyor. In middle comes G, that means green. So if something shows green on pH paper in middle, then it is neutral. Then the pH is 7. Okay. If something is showing yellow, orange or red, then it's acidic. And if something is showing blue, indigo or violet, then it's basic. The more it shows red, the more acidic it is. See there, the value of pH is written 2. And more if you go, there is basic and this side is basic. The more you go blue, the more it's basic. The more reddish, that the substance is danger, that means acidic. In the middle comes green. Green means neutral. Clear? There's some acids whose pH value you should remember. First, gastric juice. This is hydrogen chloride, hydrochloric acid. This pH is 1.2. Very strong acid. Very strong acid. Next is lemon juice. This is also quite strong. This is about 2.2. Next is pure water or blood. Its pH is 7.4. Nearly 7. Milk of magnesia means magnesium hydroxide. Metals hydroxide is base. What is the pH value? 10. Next is sodium hydroxide, beta strongest base, one of the strongest. What is the pH? 14. You must remember this. Gastric juice, HCl, how much is it? 1.2 of lemon. Lemon juice, 2.2. Both are strong. Then what comes? Pure water or blood, 7.4. Then milk of magnesia, magnesium hydroxide. How much is it? 10. And then NaOH, sodium hydroxide, very strong base. pH is 14. Do you understand the color? If green, then neutral. The more it's red, the more acidic. The more blue, the more basic. Let's do a question. It's easy. Let's do a question. CBSE 2023. Which one of the options in the table is correct? Let's see which one is correct. Let's see. Lemon juice says color of pH paper is orange. Says its approximate pH value is 3. Approximate value of lemon juice is 3 and color is orange. 2.2. Nature of solution is basic. See, it's wrong. Nature of solution is lemon juice. Nature of pH is 3. How is it possible? It's acidic. Incorrect. Milk of magnesia, magnesium hydroxide. Color is blue. pH is 10 and everything is fine. pH is more than 7. Basic. Color is blue. Everything is fine. Gastric juice. How is it? 1.2. Wrong. They are calling it pure water yellow and pH 7. What should have been there? Green. So which one is correct? Option B is correct. Chalo bhai, let's move on. Next is CBSE 2019-2025. This written 2 times, mentioned in 25. A similar question. A universal indicator was added. Universal indicator means there's something that is nature, acid or base, and the strength also. Was added to 3 test tube containing solution XYZ. The color observed were red, which is color means X is red. Red must be here. X should be in red. Green, Y gets green. Y will be here. And Z gets purple. Let's consider purple here. Purple. This is Z. Arrange the solution in increasing order of their pH. Now beta, if I'll arrange them their increasing order of pH, first will be X, second will be Y, and then more than that is Z. Which solution will turn phenolphthalein pink? Who converts phenolphthalein pink? Base does. Which one of them is base? Can you tell Z? This is what? Neutral. This is acid. So Z will be the answer. It will turn phenolphthalein pink. Next is importance of pH in everyday life. Sometimes one or two questions come from here. I'm telling you all this because this is theory. All right, I'm telling you. Our bodies, human bodies, the pH range is 7 to 7.8. Asked in last year's exam 2025, taught in last year also. 7 to 7.8. What is the pH of rainwater? If pH of rainwater is less than 5.6, then we call it acidic. It happens sometimes. There is acid rain. If there is acid, then pH is less than 7. Acid rain is harmful for them. The aquatic organisms, those living in water, acid rain will come, go to the river, aquatic life, survival difficult. Next, the stomach produces HCl, gastric acid. Which acid is formed in stomach? Gastric acid, to digest the food in stomach. Gastric acid helps in digestion of food. Okay, the pH is 1.2. Beta, it's very, very strong acid. During indigestion, the stomach produces too much acid. Sometimes you eat samosa and pizzas and then there is acidity. Acidity, what? Did that happen because of samosa? Was there something in the samosa? No. Samosa said, I won't be able to digest this samosa. Bhaiya, eating dry chapatis every day. Don't know what he ate today, which is which, friends. It gives lot of acid. Take a lots of acid, bhaiya, to digest the food. So a lot of acid comes in the stomach. So acidity forms. What acid? HCl. During digestion, stomach produces too much acid, causes pain and irritation. What is the solution? Drink ENO. What is ENO? Anti-acid. Opposite of acid. What it have? Milk of magnesia, means base. You have to neutralize the acid, so you have to put base. So this is basically example of neutralization reaction. If asked about example of neutralization in daily life, you can give this one, that when there is acidity in stomach, then what we do? We drink milk of magnesium hydroxide, then we drink, and what happens with that? Acid and base neutralizes. There is one more solution, is baking soda. Baking soda is, it's a base, it's basic actually. Put on baking soda, it releases. A lot of time you have seen mummy giving you things like salt by mixing water and asking you to drink it, then bhaiya, release acid, a lot more gas comes out, totally great. Antacid neutralizes excess of acid. Antacid, what it do? Antacid is base, so it neutralizes acid. If the pH of our mouth is less than 5.5, then it means our tooth is decaying, tooth decay. How much? If the pH of teeth is less than 5.5 of tooth, then that tooth is rotting. Why it's happened? Due to sugar and food degradation. We ate food, it sticks there, so it imbalances. What it does? It imbalances the pH of teeth. To solve this, use toothpaste. Bhai, what does toothpaste have? Toothpaste have base, that we toothpaste, which is basic in nature, neutralizes excess acid. If anywhere in the tooth it feels like there is a lot of acid, the tooth is decaying, then what you have to do? Brush your teeth. Bhai. Second, honey bee sting, right? If a honey bee stings, it swells like this. So if the sting of a bee, what it has? Formic acid it has, which is also called methanoic acid. Both are the same thing. Either bee bites or even if ant bites, both will be called formic acid and methanoic acid. What is the solution? Bhai, neutralization. Bee stings, it's swollen. Why it's swollen? Because it's acid. How to solve this? With base. So mild base we have to use. What? Baking soda, sodium hydrogen carbonate, and use baking soda. Now it's clear. Nettle stinging hair. Now what is nettle? It is type of plant. So you like playing cricket and ball rolls in the jungle, searching for it. Something bite me. It irritates. So for a long time it irritates, because nettle sting also have methanoic acid or formic acid. Painful when touched. What is the solution? Wherever there is nettle plant, there is nearby you will find dog plant, which is basic. So nature have solution for everything. Nearby you will find a dog plant, rub it with its leaf, it's basic in nature, all the problems are resolved. This is neutralization. Okay, let's see question CBC 2025. Tooth enamel is made up of calcium hydroxyapatite, a crystalline form of calcium phosphate. Wait, this chemical starts corroding in the mouth when pH is. When does tooth decay? When pH is 5.5. What is the closest option? 5. Is it? Tooth starts decaying when pH is less than 5.5. Okay. The body of human when less than 5.5. See, less than 5.5 less. So 5.5, that is one option. CBSE 2025. The body of human beings work within the pH range of 7 to 7.8. You have to remember it. It's a question of general knowledge. 7 to 7.8. It's between it. Next, look at pH of salts to find out. pH of salts, you must know one thing. What? Strong acid, weak acid, strong base, weak base. Must be remembered. Okay, let's revise this quickly. Strong acid, sulfuric acid, hydrochloric acid, nitric acid. Weak acid, CHCOOH, acetic acid, and another one I told, carbonic acid, H2CO3. These two are weak acid, these three are strong acids. In base, strong base, NaOH, KOH, and calcium hydroxide. And if I talk about weak base, then ammonium hydroxide. Just you have to remember this, weak, ammonium hydroxide. Strong base, NaOH, KOH, calcium hydroxide, well, magnesium and barium there too. In weak bases, you have to keep ammonium hydroxide, copper hydroxide. These are weak. If you will learn strong, you will learn the weaker one automatically. Let's move on. Let's see, bhai, we have strong base. Now we have to tell what is the salt. How is the salt? Acidic or basic? There are 3 steps. You will understand this in 3 steps. 1, 2, 3. First one. Salt is made up of which components? Acid and bases. Let's assume I have NaCl. I have to tell whether it's acidic or basic. I will search the acidic or basic. What is NaCl made up of? It is made of HCl and NaOH. HCl is which type of acid? Strong acid. NaOH is which type of base? Strong base. If both the things are strong, then salt becomes neutral. Big people fought and destroyed. So how it's salt? Neutral. So if strong acid and strong base will fight, salt will be neutral, pH 7. Next I took Na2CO3, sodium carbonate. I have to tell whether salt or acidic or basic. What is the procedure? Salt is acid or base. What is it made up of? NaOH and this H2CO3, carbonic acid. Which type of acid is carbonic acid? Weak acid. Which type of base is NaOH? Strong. So one is weak, one is strong. So by which side will the game go? Strong one. If one is weak and one is strong, then strong one will win. Here the base is strong, so salt is basic salt. pH greater than 7. Now we take ammonium chloride NH4Cl. Tell if it's acid base or neutral. Let's search for its acid base. Let's find it. It must be formed of HCl acid and NH4OH from ammonium hydroxide. HCl I made you memorize it, strong acid. Ammonium hydroxide I made you memorize its weak base. Now if one is strong and one is weak, who will win? The one with more strength. Who is more strengthy? Acid. So acidic salt, what will be the pH? Less than 7. You learn some, you miss some. You grab it once, learn the things. Come, let's practice. You will understand it. No tension. I will make you a lot of practice. 1, 2, 3. Come, let's practice. Come. Let's start NaCl. This salt we have to tell acidic or basic or neutral. NaCl, what is made up of? NaOH and HCl. NaOH is what type of base? You still haven't learned it by, bad kid. How is NaOH? Strong. So I have written strong base. What kind of acid HCl? Strong acid. If two strong thing will fight, how will be the salt beta? Neutral. 2 big armies fought and were destroyed. Potassium nitrate, KNO3, is made up of which component? Potassium hydroxide, KOH. And where it's come from? Nitric acid. Potassium hydroxide, strong base. Nitric acid, strong acid. Big people went and got ruined. Ammonium chloride is made up of which component? NH4OH and this HCl. Which type of base is NH4OH? Weak base. We wrote weak base. HCl, strong acid. Now the weightage will be on strong ones. Who is strong? Acid. So what will be salt like? Acidic. Clear? Copper sulfate, CuOH whole twice, and sulfate come from where? H2SO4. What is CuOH whole twice? It's a weak base. See carefully, it's weak base. So I've written weak base. And what is H2SO4? Strong acid. Now tell me what will form. This is strong and this is would win and this would be more acidic. Is clear? C, like sodium acetate. They would write like this in exam. Sodium acetate. Remember this, important, because it won't be remembered. Sodium acetate. Sodium CH3COONA. Now see what will it formed of. One is CH3COOH acid, acetic acid, weak, and one which NaOH. So this we made of weak acid and strong base. Which one is strong? Base. So what will be salt like? It's basic. Clear? We'll do it. Rest practice on its own. Come, let's do a question. CABSC 2024. An aqueous solution of salt turns blue litmus to red. Beta, it turned blue litmus to red. A blue litmus, a salt turned blue litmus red. What is salt like? It's acidic. If a salt has made blue litmus red, then it's acidic. The salt could be obtained by the reaction on. Now would the acidic salt be formed? Come, let's see. Nitric acid, strong acid. NaOH, strong base. This is making it neutral. Let's see next. Sulfuric acid, strong acid. Potassium hydroxide, strong base. This is also neutral. What is it? Weak acid, acetic acid. What is this? Strong base. What is it like? It would be basic. HCl, strong acid. NH4OH, weak base. Which one is heavy? This one is heavy. This one acidic. So this is option D. Next is CBSE 2025. I have given you homework. You have to comment. There are 3 solutions, A, B, C, and you are asked to put them in order of pH. They are 3 salts: potassium nitrate, ammonium chloride, sodium carbonate. What are they formed of? I have shown you. You comment and tell the answer of pH. One is acidic, one neutral, one is basic. Then you would arrange it in the pH. Base would be the highest pH, neutral 7, acid is less than 7. Come. Naturally occurring acids. They ask it directly in exam that tell the source of an acid. These are the things that you have to memorize. There is no other way, because someone will ask, tell me which is the lemon acid, which acid is there in tomato. Will say when ant bites, which acid is there. You have to cram it. That's why I have made some mnemonic codes for it. If you like it, it's good. If you don't like it, then say it in the comments. Mention if you like it. Come, I teach you. First of all, vinegar. It must have been come now. Vinegar, acetic acid. Vinegar means sirka, right? Vinegar had acetic acid. How do I make to memorize this? Sirka piya. Vinegar means sirka. Sirka pikar acting kiya. Now bhai went to the kitchen, took the sirka bottle and then doing acting. Hey mummy, I gotta eat my chowmin. Sirka pikar acting karne laga. What is sirka beta? It's vinegar. What comes from acting? Acetic acid came. Okay. Next, see orange. Now orange and lemon have same acid. How do you remember? Both of them are sour. What is orange like? Sour. What is like lemon? Sour. Sour means citric acid. Sour means citric acid. Both are round. You will remember this as well. What are to memorize it? You peeled an orange. You peeled a lemon. Then you can see a city inside. You peel an orange, you see a city inside. So orange chila, andar city nikli. City means citric acid. Lemon chila, andar city nikli. City means citric acid. In both of them, citric acid. You peel orange and there is city. City means citric acid. City means citric acid. Next is tomato. So we took tomato and fed it to the ox. What did we do? Tomato ox ne khaya. We fed the tomato to the ox. Ox means oxalic acid. Actually, you have to memorize it all. I'm telling you, imagine a tomato. You will go out and fed an ox. So oxalic acid. Sour milk. That is sour milk. Curd. Dahi. So we take sour milk. Milk has gone sour. What do we do? We throw it to the lake. What do we do to the sour milk? Dahi ko lake mein fek diya. Lake means lactic acid. Lactic acid. Also, you generally remember lactic acid is there. Tamarind. Tamarind is beta imli. So imli tar se bandh diya. Do you know tamarind? Imli. Imli ko tar se. Tamarind, you know. In English, tamarind. Imli, you bit very sour. So imli. Imli was tied to tar. Tar means tartaric acid. You should remember this. You will be used in future. Tartaric acid. Then ant sting on nettle sting. Ant sting means bitten by ant. Nettle means plant. Both have methanoic acid. Both have methanoic acid. How do you memorize it? Jachiti was eating methi paratha. Nettle sting, that means net. Nettle sting means net. And net, there is methi paratha stuck in it. Now these are tricks. It's upon you how you memorize it. You have to memorize it anyway. So how, why? And what did it do? Ate methi paratha from methi, methanoic acid. Nettle sting. A methi paratha got stuck into a net. You think about it. So there is an ant. What it's eating? Methi paratha. And there is a big net jali. There is a methi paratha stuck in it. Methanoic acid. Methanoic acid is we known as formic acid. You must remember it and don't get confused in examination. We also call methanoic acid formic acid. Clear? Chalo, come. Memorize it once. After pausing, then we'll do the question. Memorize. Let's move on. You didn't remember it, right? I will have to make you swear, right? You don't remember it, right? No. You swear on that girl whom you have been seeing entering the class for 1 year. You keep looking like this. If you do not remember this, she will never talk to you in her love, but you will also talk to your best friend. She might date him as well. Go. Now memorize it. Pause it. CBSE 2023. Acid present in tomato is tomato was fed to the oxalic acid over here. I finish it directly. Which of the options in the given table are correct? Chalo. Orange is peeled off, city inside, citric acid, wrong. Sour milk, there is thrown in lake, lactic acid, correct. Ant sting, what was there? What was the ant eating? Methi paratha, methanoic acid, correct. Tamarind means imli, tied to the tar, tartaric acid, is wrong. Option 2 and 3 are correct. So option 2 and 3 are correct. Chalo bhai, let's go move ahead. Next, beta, we have some chemicals whose preparations and uses we need to study well. We also have to remember direct gifted questions come from here, and this is very important and often ignored part of this chapter, whether it's school on the teachers or educators or everyone gives very less importance to this part, but its weightage in exam is very high. The learning part is here is big. We cannot ignore it. Chalo, we have to memorize some salts and their preparation and their uses. Chalo. Common salts, NaCl, sodium chloride is called common salt. It is called rock salt also. Why? Because it's found in deposits in rock beds, where it's found in rock beds. That's why they are called rock salts, common salts. It's also its name. It's a common salt we have to use in house. Common salt is raw material for various chemicals. Common salt is the biggest uses. One is salt. Yes, sir. It's fun. It's raw material for chemicals of different types. Which are the types of chemicals? One, we make NaOH. See, sodium is also called soda. In common language, sodium is also called soda. So this name is caustic soda. Another is NaHCO3. Now what is it? This is bicarbonate. Bicarbonate. And what is this? Soda. Bicarbonate soda. Baking soda. You can remember it like this. NaCO3. What is it? Soda. This is bicarbonate. So baking soda. Then this Na2CO3.10H2O. Na means soda. And this is water. So washing soda. Next is CaOH, Cl2. This is bleaching powder. Don't worry. One by one, we will study this preparation and also the uses of them. Okay, we will start one by one. How to remember Na in all of three of them? Three are sodas. This is caustic soda. This is bicarbonate, baking soda. And this is water, washing soda, washing powder, Nirma. And finally, bleaching powder. See, first is we'll study chlor-alkali process. This is very important question, always comes in exam. Very important. Chlor-alkali process. The name chlor-alkali, this name is process. This we make NaOH. What we make? NaOH or caustic soda we make, or sodium hydroxide and caustic soda. NaOH preparation it's used. What do we do? NaCl we take common salt. Actually, all these chemicals will be made from common salt. Using common salt, all these are made. So first of all, we saw how to make NaOH. We took common salt, NaCl. This, we mixed it with water and performed its electrolysis. Do you remember electrolysis? We have done with water, some cathode, some anode it goes. So we took NaCl, mixed it with water. The aqueous solution of NaCl is called brine solution. The aqueous solution of NaCl is called brine solution. Now see what will happen. Two gases will be released. One is chlorine gas, another one is hydrogen gas, and NaOH will be formed. Remember, two gases are released in this reaction. One chlorine gas, one hydrogen gas. And what are you making with chlor-alkali? What are you making? NaOH you're making. And NaOH would be released. So look what is formed: NaOH, chlorine gas, hydrogen gas. What will we write above? Electric current, because it's electrolysis. Brine solution. In exam, they will often say brine solution. If they state brine solution in exam, then understand what are we talking about? NaCl in water. Okay? Acha, this is formed. Now look where it is formed in cathode, where it is formed at anode. Hydrogen gas is formed at what? Cathode. And they ask in exam, bhai, what's formed at the cathode? What is formed at anode? So you have to remember this. There's a trick also. What? Chlor-alkali. Chlor-alkali. Do you hear chor-khali? What does it sound like? Chor-khali. Do you know khali? Yeah, the wrestler saab. WWE khali. So khali caught a thief, pack him in the parcel and throw it to China. Khali caught a thief, pack him in the parcel and throw to China. So chlor-alkali, chor-khali. Khali caught a thief. What did he pack him to? Parcel and throw it to China. You have to remember two words, parcel and China. Parcel, listen, positive anode chlorine. China, cathode hydrogen NaOH. You will remember with this. What? Parcel, China, positive anode. What is formed? Chlorine. China, what is formed at cathode? Hydrogen and NaOH. At cathode, NaOH, and cathode, hydrogen, and at anode, it's chlorine. Okay, one more thing. Now the products, this use in exam has been asked. This is chlor-alkali process. Positive is called anode. Parcel, positive anode. What is formed? Chlorine. Acha. And China, hydrogen at cathode and cathode NaOH also. China, cathode, hydrogen also, CH and NaOH too. Now let's look at the uses. First, let's read the use of NaOH. Caustic soda. NaOH, so means soda. First, it's used in making soap and detergent. Very important. Always remember. NaOH's biggest use is making of soda. We will read this in next chapter. Next chapter we will read in carbon 1. So we will read soap. NaOH's biggest use is making soap and detergent. Second is using paper. Factories also use paper bundles. What is the use of hydrogen? Hydrogen is a fuel. Hydrogen is very efficient. Hydrogen is used to make ammonia. Hydrogen is used to make fertilizers. Right, ammonia we have read. Ammonia gas, NH3. See, it's looking like hydrogen. Hydrogen is used in making fertilizers. Last one is chlorine. Last is chlorine. Chlorine, you know, chlorine is used in cleaning water. People say adding chlorine in water tasting bad. So, in swimming pool, water cleaning is also used. Second is pesticides, meaning killing the pests. You should remember at least one use of each. What is formed? NaOH, chlorine and hydrogen. What is the use of NaOH? Biggest use, make soap and detergent. The biggest use is soap and detergent. Okay. The use of hydrogen is fuel and ammonium. Chlorine used to cleaning water, clean water, so swimming pool water, and pesticides. Okay, now see, CBSE has asked a question about in 2020, haven't written it down, but let me tell you. CBSE has asked in 2020, tell 3 products of chlor-alkali process and tell one use of each one. So what are the 3 products? 2 gas, chlorine, hydrogen. What is the use? Making NaOH and state of use of each one. Now, we will see bleaching powder. What is bleaching powder? CaOCl2. Okay. This is its chemical formula. How it's made? Through chlor-alkali process, chlorine was made. Now pass that chlorine through slaked lime, through calcium hydroxide. What will happen? The chlorine will be absorbed by slaked lime. What will it make? CaOCl2. What has to be released? Water. This reaction of the manufacturer should be remembered. What is the use beta? It bleaches. Suppose there is a stain on cloths. You have to clean it. Soap is not unable to move it. Bleaching removes it. So bleaching wash clothes. Bleaching cotton and linen. Second, its very good benefits. It kills germs from the drinking water. Make drinking water free from germs. So these 2, the uses you must remember. Another one is oxidizing agent. But these 2 you have to remember. What is the next thing? Baking soda. Now see, soda. Soda means sodium. And baking bicarbonate, NaHCO3. This is the only reaction in your syllabus with 4 reactants. 4 reactants. You must remember this one. It can be used to draw Bhokal, NaCl, water, ammonia, carbon dioxide. NaCl, water, ammonia, carbon dioxide. What would be formed? First, this formed NaHCO3, sodium hydrogen carbonate, sodium bicarbonate, or baking soda. And one formed NH4Cl. So this you need to remember. 4 reactants. One is NaCl, the common salt that we had, water, ammonia, and carbon dioxide. These are formed. Okay. Now, what is biggest use of baking soda? You should remember. First, it's used to make pakoras, kara and kurkura. When mother fry pakoda at home and we complain that it's not fun, they are not kurkura, they add baking soda to the batter, and what happens? They become kurkura, crispy pakoda. The second important use is neutralize acidity. Mild base, mummy keeps it in the box. If you say you have acidity or burning stomach, so they mix it and baking soda with water and give it to you. The third one is soda acid fire extinguisher. These 3 you should remember. The 2 other you also will remember. Curding of milk, it delays for faster cooking. The cooking happens faster. This is the use. Use for making crispy pakoda. Memorize it. Frying pakoda. And remember for neutralization and soda acid fire extinguisher. See the question from CBSE 2023. What are they asking? During electrolysis of brine, a gas G is liberated at anode. When this gas G is passed through slaked lime, a compound C is formed. So it's saying that the gas is liberated at the anode through electrolysis of brine. Which gas is liberated in anode? Chlorine. Partial positive anode chlorine. Then we're saying when this gas G is passed through slaked lime, if we pass chlorine through slaked lime, then we just read it now. What does it form? Bleaching powder. Write the formula of G and C. So G becomes what? It becomes chlorine. And what does C become? Bleaching powder. Here CaOCl2. State the chemical equation involved. So this equation of brine electrolysis of NaCl equation, and second forming bleaching powder when Cl2 passes through slaked lime. What is the common name of compound C? What is the name of compound C? Common name? Bleaching powder, right? CaCaOCl2. This becomes compound. Clear? Let's move ahead. Absolutely theoretical. CBSE 2025, 23, 20, 19, 18. Questions always comes from here and students leave them. A compound X is used in kitchen for making crispy pakoras. Beta, crispy pakoda, you understand what is it? NaHCO3, baking soda, crispy pakoda. Identify the compound X. We got it. Write its chemical name. Chemical name sodium hydrogen carbonate or sodium bicarbonate. And formula. Write a chemical equation involved. How is it formed? By 4 reactants: NaCl, water, ammonia, carbon dioxide. Now see, NaCl, water, carbon dioxide, ammonia. What's made? NHCO3, NH4Cl. Mention one use of it. First, one frying pakoda. Second is neutralization. Third is soda fire extinguisher. Here is all the things written. Come. Next is beta baking powder. So you have just read baking soda, baking powder made from that. Baking powder is equal to adding tartaric acid in baking soda. What to add in baking soda? Tartaric acid. What is tartaric acid found at home? Amchur. What is amchur? That sour one. That is tartaric acid. So what do we do? That from baking soda, added tartaric acid. What formed from acid? H plus. Now look at this reaction. Think like this. This is acid. And acid and a metal carbonate or bicarbonate. Metal bicarbonate acid releases carbon dioxide. So beta, adding tartaric acid, what is released from it? Carbon dioxide. Have you seen where baking powder is used in household? Not in ours, but in rich people's house. Baking powder is used to make cakes, making breads. Then what does it do? It makes cake puff up. In exams, they might ask how the cake puffs up, like hoof. You derive it like that. So how does cake puff up? Because of baking powder. How? You added tartaric acid in baking soda. What is formed? It formed baking powder. What happens? What comes from tartaric acid? Acid H plus. The reaction of acid and metal bicarbonate release what? Carbon dioxide. The same carbon dioxide beta gets trapped in cake, causing it to puff up, making it soft. Causes bread or cake to rise, making them soft on spongy. That is all about. Washing soda. Now washing soda, from soda to Na and from washing to water. Na2CO3.NH3. How it's formed? You have taken baking soda, NaHCO3, heated it. Then what happened after heating? It changes to NH2CO3 and what released? H2O and carbon dioxide. Step 1. How was formed soda? From baking soda, NaHCO3. Baking soda, bicarbonate, sodium. Baking soda, bicarbonate, sodium. Heating NHCO3, release carbon dioxide and water. Then we added 10 molecules of water to Na2CO3. What does it become? Na2CO3.10H2O. Sodium carbonate decahydrate. Deca means 10 hydrate. Deca 10. Sodium carbonate decahydrate. You must remember this name. This is its chemical name. Can be asked in exam. Sodium carbonate decahydrate. And what is the common name? Soda and water. Washing soda. You have to remember only one function: removing the permanent hardness of water. Removing the permanent hardness of water. Repeatedly asked in exam. Okay, let's move on. CBSE 2025, 23, 20, 17 came so many times. How is washing soda obtained from sodium carbonate? Asked from sodium carbonate. So we have to state only this reaction. There is no need of this one. How is washing soda obtained from sodium carbonate? So sodium carbonate plus 10H2O, Na2CO3.10H2O, sodium carbonate decahydrate. Write the chemical equation. What is the type of this salt? Tell the type of this salt. Type means acidic or basic. Made from which one? NaOH and H2CO3. Carbolic acid forms from this one. Which type of base is this? Strong base. Which type of acid is this? Carbonic acid. Which type of acid is this? Carbonic acid. Weak acid. One strong, one weak. Strong one wins. So now what would it become? Basic in nature. Which type of hardness is removed by it? Permanent hardness. Ask multiple times. Next is beta water of crystallization. What happens to some chemicals? Have you seen .H2O? It's written. So we say they have water of crystallization. Remember the definition? Fixed number of water molecules present in one formula unit of salt. What is it? Some fixed number of water molecules present in one formula unit of salt. Like copper sulfate crystals. CuSO4.5H2. You should remember the color. Crystals of copper sulfate are blue in color. Very important. Copper sulfate is blue in color. You must have seen in last chapter, and copper sulfate is blue color. Okay. Copper sulfate crystal .5H2O. Then there is one Na2CHO3.10H2O. Whenever you see .H2O, we say that they have water of crystallization. What is this? Sodium carbonate decahydrate, washing soda. And let's see what I have. You remember this one? Last activity we have studied. Ferrous sulfate FeSO4.7H2O. Its color is green. You have to remember on the compound gypsum CaSO4.2H2O. So you must have remembered this 4 water of crystallization beta. Clear? copper sulfate, CuSO4.5H2O, blue in color. This is washing soda, clear, .10H2O. Ferrous sulfate 2 comes, there is now gypsum, calcium sulfate .2H2O. Okay, all right. Now you remember this one, you have to study this reaction in the last chapter, that ferrous sulfate crystals that are green in color, you have to heat them. What happens first? Water of crystallization released, and ferrous sulfate changes from green color to what? From white powder, remember? And then if you heat it more, then reddish brown ferric oxide it turns into. Similarly, the reaction of copper sulfate follows the same way. The crystal of copper sulfate crystals are blue in color, and after heating, water is released, copper sulfate released, what is the color? White in color. So you must remember these two things. You remember this, right? Changes from the green to white and then to brown. You studied in chapter 1, heating the ferrous sulfate. This copper sulfate changes from blue to white. Okay. Next is plaster of Paris. You must have seen plaster of Paris in your home. It shines and used to make toys. How it is made? Made from gypsum. What is gypsum? CaSO4.2H2. If you heat gypsum at 373 kelvins, 373 kelvins, it means 100 degrees, might be written in exam. If you heat, can you say dot to H2O? Remove half water from it, remove half H2O, and add half H2O to CaSO4. CaSO4 up dot half H2O. Reminder is 1.5 H2O, 1.5 is 1 H2O, 3/2 H2O. This is the reaction. Now the compound that is made, it's called plaster of Paris. Clear? CaSO4.2H2O, what is why? Gypsum. Remove half F2O and add CaSO4. Half H2O is added. This is plaster of Paris, white powder. If half is removed, how much is left? 1.5. 1.5 means 3/2. So 3/2 H2O. This is the balanced reaction. Sometimes it asks how we make gypsum back to plaster of Paris. Abey yaar, add water back to it. Add water to plaster of Paris, gypsum comes back. What is the usage? Plaster of Paris is used for making toys, making stuffs, smooth surfaces, and material for decoration. So one is made for toys, making surfaces smooth, and used for decoration. Will you remember? Acha, another thing it's used for, have you seen? It's used as bandage on after the bone is broken. So this is used for that also. But we call it plaster. So use in medical plaster too. Plaster of Paris is used when hand is broken. Had you broken in your hand? I had broken my hand in childhood, left one. So medical plaster, it's also used. Let's go. Question CBSE 2025, 24, 20, 17 and 16. What is it? Write the name, chemical formula and one use of the compound obtained when gypsum is heated at 373 Kelvin. So bhai, when you heat 373, what does it make? Plaster of Paris formula CaSO4.2H2O. What is it used for? Making toys, making surfaces smooth, material for decoration. CBSE 2025, 23, 2015. Bhai sahab. What is meant by water of crystallization? Fixed number of water molecules present in one formula unit of salt. Write the chemical formula of two salts having water of crystallization. State one use of each. So we took two. One is gypsum, CaSO4.2H2O. What is the use? Manufacture of plaster of Paris. Another one we take washing soda, Na2CO3.10H2O, used in removing permanent hardness. So here beta ji, whoever has completed the lecture with me should write down in the comments, I am unstoppable. So keep studying. Good day, Guriya. All the very